Okay, here we go, guys. So, if you recall, we talked about this function yesterday, or this equation, I should say, yesterday. Okay, and we found dy dx, and we got I think dy dx equals, what is it, 2x over 3y squared plus 2y minus 5. Okay, so we got that. Right? Very typical stuff, right? We took the derivative of all these things, isolated the y primes, and then solved for that. We got that. Okay. But that's not the only way we could take the derivative there, right? Oh. We could also find the derivative of x with respect to y. Dx dy.
Oh, I read about this in the book, and it kind of blew my mind.
A little bit. Okay. So basically, you'll notice that in our traditional way that we take the derivative, right? We take the derivative of y cubed, we treat that and make it 3y squared dy dx. So 2y dy dx minus 5 dy dx minus 2x equals then 0. All right. We did do this one yesterday, didn't we?
Yeah.
I think we did. Yeah. But now we're going to do it in a different way. We're going to find the derivative of x with respect to y. So whereas before, when we took the derivative of y with respect to x, the derivative of y cubed was 3y squared dy dx. Now, since we're taking the derivative with respect to y, what will y cubed be? What's the derivative of y cubed going to be?
3y squared.
Just 3y squared. So y cubed, I'm going to write the original here. Y cubed plus y squared minus 5y minus x squared equals 4. Okay. Yes, the derivative of y cubed is just going to be 3y squared. All right. The derivative of y squared is going to be what?
2y.
Just 2y. The derivative of 5y, or minus 5y, is just minus 5. And the derivative of x squared is what? 2x x prime, or dx dy, whichever one you want to write, okay? Because now the x has is now acting like our other variable. It's acting like the y variable in the normal problems that we do, okay? So the derivative of x squared is still 2x, but then times the derivative of what's inside the x with respect to y, so it's times dx dy. Okay? And then what's the derivative of 4 going to be? Still 0. Still 0, okay? All right. That's right. Everyone now freaks out. Right? All right. So Christian actually. What should we start doing here now? If I want to find dx dy.
Let's just take it step by step.
What should we do here now? We've taken the derivative.
We need to get dy or dx dy by itself.
Yeah, we want to get all the dx dy terms on one side, normally the left-hand side, and we move everything else to the right-hand side. So let's see here. We'll leave the negative 2x dx dy, and then what's going to be over here then?
Negative 3y squared.
Negative 3y squared.
Minus 2y.
Minus 2y. Plus 5?
Yeah.
And then
And then what? Go ahead, Christian. Next step.
Divide by 2x.
Divide both sides by negative 2x. And that's your answer. Okay. Now, will you see these very often? No. But I just wanted to kind of exercise the idea that we could take the derivative of these with respect to y.
part of the
Now, sorry?
how did you end up distributing? How did you get your right side negative?
because it was a positive 3y squared, so we had to subtract it over. It was a positive 2y, so we subtracted over, negative 2y. It was a negative 5, so we added over 5, and we have negative 2x there, and so we divide by negative 2. Now, what's that, Brittany? Yeah, it's just a reciprocal. What? Do you notice here? These are the same things, they're just reciprocals, because I can factor out like a negative 1 here. Right, so if I factor negative 1 out here, factor negative 1 out here, it becomes 3y squared plus 2y minus 5 all over negative 2x. Does that make sense that these two things should be just reciprocals of one? Oh, positive 2x. Does that make sense that these two things should just be reciprocals?
dy over dx and dx over dy.
Because these are just reciprocals. That's right. So then these are just going to be reciprocals. Mind blown, okay? Okay.
So happy.
So sometimes that just goes to show you. Sometimes you can be so involved in a problem that the obvious stuff kind of like blows right by you. But now it makes sense at least, right? I would not have known that. I would not have seen that otherwise. Okay. So either. So don't worry about that. Okay. Right. Here's the next one. Write the equation. Oh, no, sorry. We're not there yet. I apologize. My mistake.
Might need some white out.
Find all points of horizontal and vertical tangencies for the graph of x squared plus y squared equals 1. All right, so find all points of horizontal and vertical tangencies for the graph of x squared plus y squared equals 1. You could, but then when you take the square root of both sides, you can have a plus or minus, so that's going to make it a little bit tricky. So you could potentially there, yes. All right, so when we talk about tangents, Donna, that means we want to do what with this function? Find the derivative. And specifically, if I want a horizontal tangent, that's when my derivative should equal what value? 0. Or if I want to find a vertical tangent, that's when my derivative should equal what value? What's the slope for a vertical line? What do we call that? What's that slope value? Yeah, right, exactly. Undefined. Vertical slope's undefined, horizontal slope's 0. So, in other words, I want to take the derivative of this, see when the derivative is undefined for the vertical slopes, and see when the derivative is 0 for the horizontal slopes. Okay? So, why don't you guys go ahead and take the derivative of this? Go ahead, give it a crack. Okay? Give it a shot. And we'll take the derivative with respect to x here, okay? Take the derivative with respect to x. So yeah, dy dx, in other words.
Now solve for dy dx, just like get dy dx. And actually solve for dy dx, you would please. Nicely done. Yes.
Oh, like this. Good. Good.
Yes. Okay, great.
Gucci mama.
Mr. Wood, do you have hand sanitizer in here by chance?
I think
Smells like fruit snack? You're gonna want to eat your fingers.
As long as they're sanitized.
These fingers are delicious. Tastes like fruit snack. All right, Anna, what'd you get? Yes. So it should be negative 2x over 2y. Because you subtract the 2x over. And then, of course, that can simplify to negative x over y if you wanted to. Okay. So there it is. Great. So let's find the horizontal. So again, horizontal tangents when x, sorry, not when x, when dy dx equals what?
0.
Equals 0. Horizontal tangents are when dy dx equals 0. So we're going to take this derivative here, negative x over y, and set it equal to 0. Now, when is this thing equal to 0?
When x is 0.
When x equals 0.
Can that just be the answer? For a horizontal.
We'll come back to that. Let's go to vertical. Okay. Vertical tangents. That's when dy dx was what, Donovan? Vertical tangents? Undefined. Very good. Thank you. So this is harder to see here, but if I have dy dx, I can't really set it equal to anything. Okay. But what part here, or how can we figure out when this derivative will be undefined? Yeah, so let me go. Josh, what will make this undefined? Say it one more time. Slope's vertical, but I mean, what makes, that's when, so that's exactly right. That's why we want to know when this thing is undefined. But to be undefined, that means you're dividing by what number? 0. So what would have to be true here to make sure that we are dividing by 0? That's it. Y equals 0. Okay. Now, the directions said find all the points of the horizontal and vertical tangencies. Points have both an x and a y coordinate. So for example here, Josh, when we have y equals 0, that's a y coordinate for for a point. But how can we find this corresponding x coordinate for this y coordinate? What should we do? You have an idea here? What can we do with this 0? Yes, into what though? If I plug it into the derivative, remember, that's how we came up with this number in the first place. If I plug in 0 into the derivative, it's going to give me undefined into the original. Why? Because this point is going to be a point on the original function where we had that slope of undefined. So yeah, we plug it back into the derivative, or the original here, so it's going to be x squared plus 0 squared. One second, Ryan, I'll get to you there. Okay, x squared plus 0 squared. 0 squared is 0, so it's just going to be x squared equals 1. Then what do we have to do to both sides here to solve? Anybody? Square root of both sides. And so x equals
1. Plus or minus.
Plus or minus 1. Whoa, we got 2 of them. Was that your question, Ryan?
Well, no. I think I get why. I think it's a dumb question.
Well, if you want to ask it still, I'm not going to like...
Wouldn't x, if it's undefined wherever y equals 0, I was going to ask, wouldn't it just be undefined for any x value where y equals 0? But I guess there wouldn't be a tangent line for any x value because the graph at any x value doesn't exist. Right,
exactly right. Like, yeah. So, guys, if you want to hear real quick, I think Ryan had a good point here. I just want to clarify. So the slope, this thing, the dy dx, right, equals negative x over y. Ryan's like, well, if y is 0, then x could be any number up here, and he's right. X could be any number. This is talking about the derivative, though. But if we go back to the original function, if I put 0 in for y, x cannot be any number. It has to be only 1 or negative 1 to make sure it's on the actual graph. So that's why we have those 2 points. Okay. So Josh, very good. And then Josh, I know I'm still asking here. So now for this, then this is an x coordinate. Where should I plug this then to get more points? to get like the matching y coordinate. So again, now I know that 0 is an x coordinate. What should I do with that 0? Where should I put that 0 to get the matching y coordinate? Back in the original as well. Exactly right. So it's going to be 0 squared plus y squared equals 1. So y squared equals 1, and so y equals plus or minus 1. Beautiful. All right, so 0, 1, and 0, negative 1. Okay, and those are your horizontal tangents. Now, does anyone recognize what this would be if we graphed it? It's something from pre-calculus.
Find out.
Let's find out. So, in order to graph this by hand,
It'd be a circle.
it would be a circle with radius of what?
1.
1. And centered at
Origin point.
the origin. So if we subtract x squared from both sides, you get y squared equals 1 minus x squared. Square root both sides, it's y equals plus or minus the square root of 1 minus x squared. So it's the unit circle.
Is it possible to do that on your calculator?
Yeah, absolutely. Let me show you. You do this. You have to do 2 of them. And then negative square root of 1 minus x squared. And then if you graph it, whoa, my axes were. You get a football. See, it's a circle. Nah, you got to do here is like you got to square it up, zoom square. That makes it look more gooder. And if you like zoom in some, not zoom, I think zoom decimal will make it look better. There we go. Look at that.
That's very nice.
Pretty. So let's convince ourselves we're right. So Josh said we have the points 1, 0, negative 1, 0. Does it look like we should have a vertical tangent at 1, 0?
Yeah.
Yeah. Negative 1, 0? Yeah. Okay, should we have horizontal tangents of 0, 1?
Yeah.
Yeah. And 0, negative 1? Yeah. Okay. So there you go. Put those vertical tangents in and make it look like a TIE fighter. All right. Moving on. Questions on that? So there's a bit of an application there with that. Okay, let's see. Derivatives and things. I'm going to do dos mas. 2 more. Okay. So we'll have a good bit of time here to hopefully work on your homework. All right.
I'm done with that.
Determine the equation of the line tangent to the graph of So determine the equation of the line tangent to the graph of x squared plus 4y squared equals 4. Is this going to be a circle?
Slightly.
It's going to be an ellipse, actually. What's the giveaway there, Joey? Or why'd you say that?
Just because they're different. The 4.
Yes, this y squared has a 4 in front, whereas the x squared does not. So it won't be equivalent. Okay, it's going to be like skewed basically. So at the point root 2, comma, negative 1 over root 2.
We just always assume it's dy dx.
So yes. Assume dy dx unless otherwise specified. So actually I'm going to have you guys go ahead and try this. So give it a shot. Okay. Alright, I'm going to do it real quick and I'll walk around and provide assistance.
Yeah. Because 4 is the... Review, Brian.
Okay.
It's the same thing except it didn't have negative 2.
Stock, you're gonna be able to look at something, we can do that. Right now, we're just finding
Oh, I
line
do.
weight,
I do.
tangent to
It's
that.
not even the hard part of the
At that
problem.
point.
No, I'm talking about the slope.
Oh.
No, I did something wrong.
Oh.
I think.
If you want me to get you
Wait,
something
where did
done.
you plug in to find the slope?
On the slope.
Yeah.
You have to plug them both in. You have to plug
So, that
root
is
2 in for
slope.
x and negative
But we can
1
actually find the, that's
for
not
y.
the specific slope, right? We can find the actual slope number.
Oh, wait, I forgot that. I canceled out X, but I should.
So otherwise, yeah, that's right, but you gotta find, plug in the point. Right idea, guys, right idea.
Good.
Oh, no, it's 2.
You won't have.
Because you have negative 2 over 4 over root 2. So you need to multiply.
Well, because wouldn't it?
You have 5 prime equals
Y'all doing all right?
negative, because it times 4.
So
It's
that's
just
root
root
two,
4
right,
y.
negative what you do, you wanna write the equation of a tangent line, of two pieces of information you
Yeah,
need.
but you get negative x over 4y.
Slope. And a point, so we got a point, there it is. How would you write the slope then? Derivative,
Oh, yeah, it is negative.
now,
Minus negative 4 over root 2. You multiply that by root 2.
nope, that is the slope
4.
of this curve, but that's like the generic slope, right? That's like the slope of this curve at any point. You don't want the slope at just any point. Where do you want specifically the slope? At that point, so what you do is that.
Look what I did. So I did. So I got negative root 2 over negative 4 over root 2.
You need to multiply it by negative root 2 over 4 to cancel out the bottom.
No, I can't. No, because can't you just multiply
Away
by
the trash
the
can.
reciprocal of the numerator?
No, there's no denominator.
So, it's so interesting. I've never had students do this before. It must have been something that I did. So this, okay, that is the derivative, that is the slope, but that's like the generic slope. That describes the slope at any point of this graph. Am I interested in the slope at any point of this graph? No. Like, yes, you are. You want this.
Oh, aren't you want this?
No, I don't want that. I just want all the slope at what point? That one. So what should I do with this thing? Plug it into the derivative. Yeah, you gotta simplify that now.
Kind of simplify that down.
I was like, magnify this thing. That would be okay. Come on, that one. Come on. I know you came in late today. You got to sleep in a little extra. Yeah, sure. We're gonna do it after all.
Do you guys do your 40s on Friday?
We haven't done recorded sprints ever.
I
Oh,
don't know
okay,
why
so
he's having such a hard time measuring out 40 yards. I know, I don't understand why that's
There's so many ways just to like figure that out.
So when you did that messed up your derivative.
Literally, the football field has line. I should just tell them. The practice football field has lines on it. I don't know why.
Why?
I'm telling them. I'll be like, the practice football field has lines on it. You just go out there.
Won't there be?
Count out 4 10-yard stretches.
Okay, well, I would be, all right.
Yeah, exactly. So
But it actually works.
I mean, that's what I'm doing. If they're doing it at 5, football team's done practicing at 5:30.
Yeah.
I mean, the lines are kind of like hard to see. But they're there.
There, no.
Okay, you guys got it all right?
Yeah.
Euthene. Positive 1/2, x minus root 2. Okay, yeah, that looks good. You guys all have the same answers then? Yeah, looks good.
It's supposed to be negative.
Looks good then.
Bam! Blammo.
No, it's y plus 1 over root 2.
Oh, no, I fixed it, but I didn't. Doubted myself.
Okay.
So, did you have any word to start with that?
Ryan's getting there.
Yeah.
The derivative, exactly right. So again, what's the derivative of x squared with
I was
respect
at
to x?
Salisbury.
Too busy getting in a car crash.
I was at Salisbury. I drove home from Salisbury yesterday for 3 hours. And then my mom was like, right before we got home, she was like, oh yeah, we gotta pick up this car for brownies and walk until like 4 more places. So I was like, alright, we'll just go there right now. And literally, then I got hit. Didn't even have to go there. Could have just went home. I drove for 3 hours and was fine.
You keep going for 50 bucks a day.
So
boring.
I actually got 1/2.
I don't like it.
Come back
forward. I start weaving out of the wings and going with that. My dad yelled at me. It's so easy, but it's so boring. It requires zero concentration. It's like highway hypnosis.
Apparently, I've heard like a lot
I'm talking Route 50 to Ocean City.
Oh, yeah.
It goes all the way to Ocean City. That's how I got it.
Yeah. I wasn't sure.
It's negative, right?
So,
It is negative because it's a negative 1/2.
This was positive 1/2. Because the derivative, it's negative x over 4y.
That's right, yeah. You cancel out.
Okay, so let's do it. So now, like, so I guess how to make a fraction to a fraction. So let's take it each time. So 4
Then I've done the
negative
20.
1 over root 2, negative 4 over root 2.
You gotta
Over
find out.
negative 4 over root 2.
So it's
Right
1/2.
now.
I saw at the Y, I saw like a 5-year-old kid with that watch on.
When you have a fraction.
Yeah, I don't
fraction,
think
just divide.
Some things got, like, I wear mine pretty tight, because it's not much room for it.
No, and like,
Root 2 times root 2 is 2.
expensive watch.
Yeah.
2 over 4.
For a child.
Yeah, for a child,
I
pretty
would
expensive
more
watch.
like that.
So then, so it's negative.
I get my
negative
KD shot.
2, right, over negative 1.
I actually get him a world time watch. Yeah, it's like $30.
I already told you all.
Yeah.
I like it.
It would look really cool if it was
Okay.
Alright.
I want the calculator watch.
Alright, folks.
I want a Rolex black.
There it is.
I watch so cool.
Okay, there's what you should have gotten. Alright. Mac, I know that you came in a little bit late, but there's your derivative, right? If we want to find the slope then, so this is the, guys, and again, I really want to make sure, because I saw a couple people do this, and so I just want to make sure I really hit this home, okay? This is the slope, but it's the slope for any point. So this thing will, like, never really ever go into our equation for a tangent line. We don't use it. We don't put that into the tangent line slope. We use this to find the tangent line slope, okay? And how do we find the tangent slope? Well, we plug in this point. This is the point where we want to find that tangent slope. So we plug this point into the derivative. That then gives us the slope number of 1/2, okay? Negative root 2 goes in for the x. Negative 1 over root 2 goes in for the y. It's a little bit weird to simplify, right? You get negative root 2 in the numerator. 4 times negative 1 over root 2 is negative 4 over root 2. Dividing by a fraction is the same thing as multiplying by its what? Reciprocal. So negative 2 over negative 4 over root 2 is going to be negative 2 times root 2 over negative 4. Root 2 times root 2 is what? 2. Okay, so negative 2 over negative 4, 1/2 is the slope. And there's your equation. Boom. Okay? Next. Oh my goodness, do I really want to do this?
Let's do it. Come on, let's do it. Challenge yourself.
All right, we're going to challenge ourselves. We'll do this one together, though, because it's a hassle and a half.
Hassle and a half.
Yeah.
It's a hassle half.
Dang
So
it.
it's not a hassle half, it's a hassle plus.
Hassle half.
All right, hassle and a half. Yeah, like this much space. I'm going to use pretty much the rest of my paper here. All right, you're going to need it.
Ready to go.
Determine the slope
No.
of the normal line. Normal. We'll define that in a second here. Oh, yeah? God bless you.
That equals 10.
He made a mess in on his
What does
paper
that
there.
equal to, Mr. Wood?
3, sorry, hang on. Okay. I see I'm off the paper. 100 XY.
What? Oh, I thought it was going to be 10. 100 XY.
Okay, so normal. What does it mean to be normal? Right?
SpongeBob.
Well, just look at me.
Let's ponder that for a second. No, I'm just kidding. All right, so in math, it is a line perpendicular to the tangent line at the same point.
So it's like, so it's not the inverse derivative, is what you're saying.
So what you do is you do the normal work you would for the tangent line slope.
And then find the z.
But once you get your tangent, so for example here, in this previous problem we were doing a tangent line. What is the slope of the tangent line we found? 1/2. What is the normal slope? -2/1, opposite reciprocal. Okay, right? The slope perpendicular to 1/2 is the opposite reciprocal, and -2/1. So that's it. That's all that would change. You just take your tangent slope and just do the opposite reciprocal to get then the normal slope. It's that easy. Okay. This, by the way, is something you should be familiar with. Normal. Okay, so don't forget that, or know it now because it could show up on a future assessment or problem or something. Okay. All right. Let's take the derivative of this thing. Wow, this looks like a lot of fun.
How do you know what
Product
that
rule,
is?
product rule, product rule.
I know what is
Like, what that line?
the normal line.
Man.
No,
There's a product rule
the
here.
equation.
This
Yeah.
we have to find the derivative of that.
But how do
How do you take the derivative?
What is that?
This is an equation of this is an
Wait,
equation. This
random
relates
equation.
X and Y. I can't graph this using these calculators, but I might be able to graph it using some other stuff potentially. I don't know. I have to take a look. There might be like an applet online. Like you're trying to ask, like, what does this even look like, kind of thing.
Well, I'm just like, what does that mean?
It's just a function that we're given, or an equation that we're given, not necessarily a function. It's an equation that we're given, so we have to take tangent. So, to find the slope of a equation, what do? Take the derivative. So we have to take the derivative of this thing. Okay, so let's take this a step at a time here. So, this left-hand side, all right, when we take the derivative of something squared, what rule are we going to be using here? The chain rule, okay? So, what's going to happen to this 2 right here? It's the outermost layer, comes out front, becomes 6. We leave what's inside, x squared plus y squared, lower the power by 1, so 2 becomes to the 1 there, times the derivative of what's inside, so the derivative of 2x, the derivative of x squared, 2x. The derivative of y squared, 2y, dy dx, because we're taking the derivative with respect.
dy dx on that, so.
Okay. Like so. That's the left-hand side, equals, that wasn't that bad, right? Not that bad. Equals 100 dy dx, right? No, Mr. Witt, stop trying to trick us. What do we have to do here? It's a product rule. So I'm going to do, there's the first thing, there's the second thing. So I'm going to do the first, 100x, times the derivative of the second. Derivative of y is y prime or dy dx. I'm going to write dy dx here. Plus the second thing, y, times the derivative of the first. What's the derivative of 100x? 100. Okay?
100.
Times y.
Times 1 if you want.
Or times, I said times y, but...
Oh, yeah.
How come, like, the 3 in the first part, you just treat it like normal?
It's a coefficient.
Coefficient in that case?
You could do a product rule there. It'll end up being the same thing as this, though. Yep, it's a coefficient, so you can just pull that 2 out front.
What if it was 3x?
Whoa.
Yeah, 3x product rule. Okay? Okay? Questions on that so far? So now we have the fun of solving for dy dx. Or do we have to here?
No.
What could we do to maybe help ourselves out before we start trying to isolate dy dx? What could we maybe do because of the problem that we're doing? What could I do right now?
Simplify.
So what do you mean by simplify? So I would argue when we solve for dy dx, we're kind of like we're solving or maybe it's not simplifying, but what could we do right now? Ideas here? So let me say this: we don't need to solve for dy dx first. Right? The problem does not say find dy dx, then find the equation of the normal line. All it says is to determine the slope of the normal line of this at this point. So do I need to solve this thing in terms of dy dx right now? No. What could I do instead? Plug in the point as it's currently written. Now you might think to yourself, oh, that's going to be crazy, but not really, because we can simplify the arithmetic once we plug in the points. So why do all that work to solve for dy dx, right? So here in a previous year, we solved that thing for dy dx first and got y prime equals that mess and then plugged in our number. That's not necessary. That's not necessary. Instead what we can do is go ahead and plug our point in right now. So let's do that. So it's going to be 6 times what goes in for the x, 3 squared, and y squared, that's going to be 1 squared. Let's see, 2x is going to be 2 times 3 plus 2 times 1. Times, now, what do I plug in for the dy dx? Nothing yet, right? We're going to be solving for that. So that's going to stay in the problem. We're going to leave it, dy dx. Okay, equals, let's see, 100 times what goes in for x? The 3. And again, dy dx stays because we're going to be solving for that. And then y is 1 times 100. Okay, so let's see here. So 3 squared is 9, plus 1 is 10, so I get 6 times 10, times, let's see here, 6 plus 2 dy dx equals 300, okay, dy dx plus 100. Okay. So let's hear. I can simplify this 6 plus 2 dy dx to be 8 dy dx, right?
No.
No, I can't do that. These are not like terms, right? 6 plus 2 dy dx is not, they're not like terms. This is the number 6. This is 2 dy dx. So we can't add those together, so we have to leave those kind of separate. But I can still do the 6 times the 10 to get 60 there. So 6 plus 2 dy over dx equals 300 dy dx plus 100. Okay, so, all right, we've kind of simplified things here, but now we need to get, what do we need to solve for here? Dy dx. So we still have some work to do, so what should I do next here? What do you think? Distribute the 60, so we get 360 plus 120 dy over dx equals 300 dy over dx plus 100. So yeah, now we have dy dx on both sides. So I got to move, right? I got to get these dy dx's together somehow. So how can I go about doing that? So we could subtract 120 dy dx from both sides. I don't know, why I'm writing this out so explicitly, but there it is. Okay. I feel like you guys back are in Algebra 1 now, right? So what is that? 180 dy dx plus 100. Subtract 100, so we get 260 equals 180 dy dx. And then last step, divide by 180. So 260 over 180, which is the same thing as 26 over 18, which is the same thing as 13 over 9. So our final answer is 13 over 9.
No.
It's not? This is the slope of the what?
Tangent line.
Tangent line. How do I find the normal slope?
Perpendicular.
Normal slope. Right? And there is part of the complexity of these problems, right? You do all this work, and you like get down to 13 over 9, yes.
I guarantee that's multiple
But it's
choice.
wrong. Negative 9 over 13. Right. I mean, yeah, you can see, right, this could be a multiple choice. So please, guys, please, always make sure you are answering the question that's being asked. That is a tangent slope. That is the normal slope. So that is the answer, negative 9 over 13. Now, real quick. Real quick here. You got to know your stuff, right? Real quick here. I want to point something else out. This. If you had chosen to solve this thing for y prime, and get everything like y prime equals, and then this mess with the x and y's mixed together. Okay. If you wanted to, right? If this were like a free response question or something like that, you could plug in the 3's for the x's, the 1's for the y's. So there it is, and you could literally write -1 over that mess, and that would give you the opposite reciprocal, and that would be an acceptable answer.
But then you still need to write the equation, the line.
Well, so actually in this case, all I asked was the slope.
Oh, never mind.
So all we asked for was the slope. So all you had to do was just put -1 over that mess. And again, you don't need to simplify it. You just leave it like that. -1 over that, and that is an acceptable answer for a free response question. You do not need to go any further, because it's all arithmetic at that point. Okay? So, that's it. All right, questions on any of that?
So would that only took me like not even that page?
I'm sorry. I promised you much more epic problems. Okay?
I think